You have already checked the time today. You have almost certainly done it more than 50 times, and you can remember doing it maybe twice, on your phone, on your wrist, on your laptop, on your oven, in your car, at the top of a screen you were not even properly looking at. There is a number somewhere in your vision right now telling you exactly what time it is, down to the minute, correct to the second, and you have never once wondered where it comes from. You know what time it is because a device you own is quietly agreeing with several billion other devices about a number. Nobody in your house said it. Nobody in your town said it. It arrived already correct from somewhere else entirely, and you accepted it without a second's thought. The way you accept that water comes out of a tap. So here is the question. For hundreds of thousands of years, there were no clocks, no watches, no phones, no bells, no timetables. And yet people still had to meet, still had to work, still had to know when to plant and when to leave and when to come home. So how did ancient humans tell the time? Now you probably think you already know roughly what the answer is. You are imagining a worse version of your own clock, a sundial instead of a phone. Same basic idea, just less accurate. That is not what happened. They did not have a less precise hour. They had a completely different kind of hour. One that changed size. Let me show you, because once you see this, you cannot unsee it. Start with the only clock nature ever handed anybody. The sky. The sun rises, crosses, and sets, and that is the entire instrument. Everything else is a refinement of it. And for most of human history, the sky was not a bad clock. It was a superb one, for the things people actually needed. It told you when to get up, when the heat would become dangerous, when to start walking home so you would arrive before dark. That is not vague. If you have ever watched shadows all day, you know they move faster than you expect, and you can read them too within a few minutes with practice. But notice what that clock cannot do. It cannot mark a moment in advance and hold it. It cannot tell you to be somewhere at 2:15. It can only tell you where you are inside today. Which brings us to the strangest thing in this entire story and the part almost nobody knows. The Egyptians divided daylight into 12 parts. The Greeks kept it, the Romans kept it, and medieval Europe kept it for well over 1,000 years after that. And it sounds completely familiar, because 12 is a number you recognize from a clock face. But look at what they were actually dividing. They were not dividing the day. They were dividing the daylight. Sunrise to sunset. Cut into 12, whatever the daylight happened to be, which means that in high summer, when the sun is up for 15 hours, each of those 12 hours is long, and in deep winter, when the sun is up for 9, each of those same 12 hours is short. At the latitude of Rome, a summer hour ran to about 75 minutes. A winter hour was closer to 45. Sit with that. The hour was elastic. It stretched in summer and shrank in winter every single year, and everybody knew it, and nobody thought it was a problem. Because the hour was not a fixed quantity of time, it was a fraction of the working day. The first hour was early. The 6th hour was noon. The 12th hour was the end. That was all anybody needed it to mean. Your hour is a unit. Their hour was a position. So when a Roman agreed to meet somebody at the 3rd hour, he was not agreeing to a duration. He was agreeing to a place in the shape of the day. And in December that meeting would arrive sooner after sunrise than it would in July. And this bothered absolutely no one. Now sundials only work when there is a sun, so the obvious problem is night and cloud and indoors, and this is where things get inventive. The oldest solution is water, a vessel with a small hole in it, draining at a steady rate with marks up the inside. Fill it, and the falling level tells you how much time has gone. The Egyptians had them well over 3,000 years ago, the Greeks refined them, and the Romans used them to time speeches in court, because a water clock is the perfect tool for cutting a lawyer off. China and Japan burned incense in carefully mixed sticks and spirals, sometimes with different scents in sequence so you could smell how late it was, and sometimes with threads holding small weights that dropped into a metal dish to wake you. That is an alarm clock, in the 9th century, made of smoke. In England, there is a long tradition attributing marked candles to Alfred the Great, burning down through painted bands so he could measure out his day. But notice what all of these have in common. Every single one of them measures duration, how long has passed, not what time it is. A water clock does not know it is Tuesday afternoon. It knows how much has drained since somebody filled it. You cannot walk up to one cold and ask it the time. Somebody has to have started it, and watched it, and reset it. Which is why the real breakthrough was not a clock at all. It was somebody whose entire job was to watch one. In medieval monasteries, prayer had to happen at fixed points, day and night, and missing them was not an option. So monks kept the water clocks and the candles and watched the stars through slits in the wall, and when the moment came, they rang a bell. That bell is the most important object in this whole video. Because the bell meant that for the first time. One person's measurement of time could be pushed out across an entire community at once. You did not need to own a clock. You did not need to be able to read one. You just needed to be within earshot. The whole town ran on somebody else's instrument, and the word we use for the machine comes straight from that. Clock is from the Latin for bell. By the late 13th century, mechanical clocks were appearing in European towers, driven by falling weights and a clumsy little oscillating mechanism, and they were, by your standards, dreadful. They drifted by many minutes a day. They had to be corrected constantly, and they were corrected against what you would expect. A sundial. The great machine was checked against the sky. But they had one enormous advantage over everything before them. They ran on their own. Nobody had to fill them or light them. They just went. And a machine that just goes can strike a bell in the middle of the night without anybody being awake to make it happen. Here is the detail that tells you how differently people thought back then. Those early clocks very often had no minute hand. Some had no hands at all, just a bell. And that was not because nobody could build one, it was because there was no demand. Think about what a minute is for. A minute is for coordinating with somebody who is not with you. It is for catching something that will not wait. If your whole life happens within a mile of your house, among people you can see, and the things you are waiting for are the harvest and the tide and the season, then a minute is not a useful piece of information. It is noise. The hour was fine. Honestly, the half-day was mostly fine. The minute hand only becomes normal in the late 1600s after the pendulum arrives and clocks suddenly become accurate enough that a minute is even a meaningful thing to display. Your great obsession with the small units is roughly 350 years old. Everything before that ran on a coarser grain and ran perfectly well. And now we get to the fact that genuinely breaks people's brains, because it is much more recent than anyone guesses. Even once towns had clocks, there was no such thing as the time. There was only the time here. Every town set its clock by its own sun. Noon was defined as the moment the sun was highest over that particular place, and since the sun does not arrive everywhere at once, noon in one town was simply not the same instant as noon in another. In Britain, Bristol ran about 10 minutes behind London. Not wrong, not badly calibrated, just further west. And for all of human history that was completely fine, because nothing moved fast enough for the difference to matter. A letter took days. A person on a horse took days. If you arrived 10 minutes out of step with a town, you would never know, and neither would they. Then somebody built the railway. And suddenly you had a machine crossing 100 miles in a couple of hours, running to a printed timetable on shared track while every station along the line kept a different clock. That is not an inconvenience. That is a collision. Two trains can be perfectly on time according to their own stations and still be in the same place at the same moment. So the railways did something extraordinary. They overruled the sun. Britain's Great Western Railway put London time on its whole network in 1840. Other companies followed, and by the 1850s most British towns had given up their own noon, sometimes with real resentment, because a town's time was a town's own. Some clocks were fitted with a second-minute hand for a while, showing both London time and local time, which is a lovely image of a country in the middle of changing its mind about what a moment is. America went the same way in 1883, when the railroad simply drew standard time zones across the continent and imposed them. The day it happened, some cities experienced noon twice. And in 1884, an international conference in Washington settled on Greenwich as the world's reference meridian. And the modern grid of time was essentially finished. So the time you live by is not astronomical. It is administrative. It was not discovered. It was negotiated, fairly recently, mostly by railway companies, because trains needed everyone to agree. Picture the older world properly for a moment. It is late morning, several thousand years ago, and you are working outside. Nobody has told you what time it is, because there is nobody whose job that is. You know it is late morning because the shadow of the wall has pulled back close to its base, and because the heat has changed character, and because you are hungry in the specific way you are hungry at this point in the day. Someone said they would come when the sun cleared the ridge. The sun cleared the ridge a while ago, and they are not here, and you are not remotely concerned. Because coming when the sun clears the ridge means this part of the morning, not a moment inside it. You are never late. You cannot be late. The concept requires a shared instrument that nobody has invented yet. Nobody in that world has ever felt the particular modern feeling of watching a number change and knowing you will not make it. That feeling is not ancient. It is a side effect of precision. And then look at where it ended up. The second is no longer defined by the Earth at all. Since 1967, it has been defined by counting oscillations inside a cesium atom, over 9 billion of them, because atoms are more reliable than planets. There are atomic clocks and satellites over your head right now, and your phone is quietly checking itself against that network, and that is why you have never in your life had to set a clock by looking at the sky. Here is the part that ought to stop you. The Earth's rotation is slightly irregular. It wobbles and drags and does not keep perfect step with the atoms. So every so often, timekeepers have added a leap second to bring the two back into line. Read that again. When the planet and the clock disagree, we do not adjust the clock. We patch the Earth. For almost all of human history, the sky told people what time it was, and the instruments were judged against the sky. A sundial corrected a tower clock. The sun defined noon in every town on the planet. Time was something you read off the world. Now we hold the definition, and the world is the thing that gets corrected. Ancient humans never once knew what time it was, in your sense. Not because they were primitive, but because the question you are asking did not exist yet. There was no instant to know. There was morning. And there was the shadow at the base of the wall, and there was the bell if you were lucky enough to live near one. You have the exact time always, everywhere, for free on a device in your pocket. And you still feel like you are running out of it.